So tan of x plus x minus 30, so we're going to do the opposite of the negative, which is 30. So I'm going to move this graph 30 to the right. So actually my graph's going to start here. Now normally I have graphs, asymptotes at 90 degrees, so if we add 30 onto that, that means we're going to have an asymptote at 120. But I also normally have one at 270, so if I add on 30 to that, then that means I'm going to have one at 300. And then I should be able to do a pretty reasonable job of drawing this graph in now. Now it normally goes through the axis at 180 as well, so if I move that 30 to that side, that's going to be 210. And normally it goes through 360, but as we're moving it 30 to the right, it's actually going to go through 390, so I can probably do a slightly better job there. I can guess that's going to be 390. And that'll be my graph of tan of x minus 30. A little complicated to do that one. Cotangent x plus 60. So the graph for cotangent is the one that comes down like this. But I'm going to move it 60 degrees to the left. Now for this one, there's normally an asymptote at 0, which should go off the screen if I do that one. There's an asymptote at 180, which is going to move to 120. There's also one at 360, which is therefore going to move to 300. And from here, I should be able to do a pretty good job of drawing this in. Now the place where it hits the x-axis normally is going to be 90 degrees. So if I move that to the left 60, I know it's going to go through 30. And also normally it goes through 270. So if I move that 60 along, I should be looking at 210. So I think now I should be able to do a pretty good job of drawing this graph in. And I can't actually fit the whole graph in because the next point where it would intersect is going to be slightly off the graph, so I'll have to leave that point there. Sine 6x, that means I'm going to fit 6 graphs in. So normally this repeats over 360. So 360 divided by 6 means actually it's going to repeat every 60 degrees, which means that it's going to do half the graph in 30 degrees. So actually my graph's going to look like that. So it goes up to 1, down to -1, and as it repeats after 60 degrees, by the time I do this 6 times, that means that I should get to the end of the graph. So already at 180, I've got 3 of these graphs in, and I should be able to finish off the rest of this now. And that would be sine 6x. Cosine of x over 2, so this is cosine of a half x. So that means that actually we're going to stretch the values out. So normally cosine intercepts at 90 degrees, so actually I've got to double that to make it 180. Now normally at 180 equals -1, so I'm going to have to double that then. So actually at 360, this is going to equal -1. So this is going to be a very flat looking cosine graph, but you can sort of imagine that being half of a cosine graph, hopefully. Probably not a very good choice of scale by me for that question. Cosine of 2x and 2 cosine 2x. So cosine 2x means we're going to fit 2 of the cosine graphs in. So normally it would repeat after 360. So for this one, it's going to repeat after 180. Also, I'm going to have to double the values as well. So instead of starting at 1, I'm going to start at 2. So if it repeats after 180, I can already put that point there. And also for 360. Now normally the halfway point comes at 180, so if we half that, it means it's going to come at 90. And also I'm going to need to double that as well. Now for my other values, cosine normally hits the x-axis at 90 degrees, so if we half that, that's going to be 45 degrees, which is going to be like here. And I think I can probably have enough points now to come up with a reasonable graph for this one. Oops, got a little out of control there. There we go, not too bad. But you can certainly see that we managed to fit in 2 cosine graphs within that period. And also it goes from 2 to -2. Okay, last one. 1 minus tan x over 2. Now this is a little bit sneaky because it's actually written the wrong way round. What I really want to do is say this. Negative tan of x over 2 plus 1. And I got quite a few things to think about here. The plus 1 is going to be the last thing because of order of operations. The x over 2 means I'm only going to fit half of the tan graph in. and the negative means I'm actually going to have to flip it over. So normally I have an asymptote of 90, but as we're doing 1/2, we've got to stretch this out. So actually the asymptote for this one's going to be 180. And then we normally have another one as well at 270, which would push that out to 540, so we're not going to include that one as part of our graph. Also, other key values. Normally we have our x-intercept at 180 degrees. So if we double that, that means we're going to have our intercept at 360 degrees. Now there's a couple of other things as well. We've got to flip this graph, and then we've got to add on 1 to it. So instead of going this way, we're actually going to go this way. But I need to add on 1 to it. So there's adding on 1. And notice when I came back down as well, in theory this should come down to 0. Whoops, I just moved the graph a little bit, which I didn't mean to do. Let's see if I can put that back. There we go. So normally it would come down to 0, but as I've got to add on 1 to this, it's going to look like that. So I think that's a pretty reasonable attempt at that last question.